guys, how's it going? This is the tutorial video for week 3. Let me share my screen with you guys. Alrighty. So this is what your Moodle page should look like more or less. And so this guy is basically just an overview of how to use an engineer scale. If you took my class last semester, we use these a lot. And basically, this is like what they look like. Basically, it's got it's like a triangular prism sort of thing. And each side, or each side of the triangle actually has 2 sides. So this side has a 10, the other side may have a 20. And basically, that's the difference between an engineer scale and an architect scale, is that these are intervals of 10 from 1 to 6. And the architect scale would be fractions. So it would be like 1/16, 1/32, and so forth. And so for this class, this would be helpful to have one of these. If you don't have one, it's really helpful to make sure that your prints come out to scale and that you can actually figure out more details than may or may not have labels, just using the architect scale or engineer scale. Alrighty, and so basically, this is just a PDF explaining how to use it. So normally when you already have a drawing that's printed out, it will determine the scale on your title block. It'll say, this drawing is a 1 to 60 scale, or your viewport set up to 1 to 60 scale. So when you print that off, you can use your engineer scale on the 6/0 side, and then, one unit on that scale is equal to 100 feet or 10 feet or whatever, depending on what your viewport setup and how big your drawing is. And it's the same thing with all these other intervals, 10, 20, 30, 40, 50. And these could also be 100, 200, 300, 400, 500, or 1,000, and so forth. But it's also important to note that there are no 70, 80, or 90 on this scale, because there's only 6 sides, right? So when you set up your viewports in AutoCAD, you want to make sure that you don't ever use an interval of 70, 80, or 90. So don't ever use a scale of 1 inch equals 7 feet, or 70 feet, or 700 feet, 7,000 feet, because when you print that off, you won't have anything on your engineer scale that will work with that scale. All right. And yeah, so we are going to go a little bit over horizontal alignments. If you took my class last semester, we did a lot of these. This next image right here is just an example of horizontal alignment. So here's your scale. If you were to print this out on a letter size piece of paper, this is 1 inch literally on the paper. So in order to figure out distances, you would actually, have your engineer scale, rotate it to the side that says 50, because right here it's an interval of 5, right? So this is 1 inch equals 500 feet. And so from here to there should be 1 inch literally on your piece of paper. So you can also use that scale to figure out other distances, like from here to there, or from any point that you really want to. All right. And normally in alignment, you'd want to start with 10 plus a pair. Okay, so that basically represents 1,000 feet. And the reason why you want to start at 1,000 instead of at 0 is because in case you need to add the alignment the other direction, you don't want to have negative numbers. So what you do is you just start with 10 plus a pair, and it gives you a buffer zone of 1,000 feet in case you need to scoot back a ways. Alrighty. And this is the actual assignment for this week. And so you're going to need to, you don't really need to print this off per se, but it might help you so you don't have to swap back and forth between screens. And you're going to need to download this Excel file, master Excel, right? So this is an example of what a surveyor would probably give you. All right, he's going to go out and survey a bunch of points. And he will have, your point number, northing, easting, description. All right, PNEZD, or elevation, and then description. And so basically, this is the data that is stored from your total station or your surveying equipment. And so what we're going to do is actually save this Excel file as a CSV or a comma delimited version of it so that we can import it into Autodesk. All right, because you can't just import an Excel file into Autodesk. You have to save it as a version that's compatible. So I'm going to show you how to do that real fast. And basically this first part here is just kind of a quick review of what Civil 3D tools we have available. So in the survey tab of tool space, it has 4 components. I'm going to show you what those are. We kind of went over this last week a little bit. So basically this is the difference between Civil 3D and just AutoCAD, is that you have the Civil 3D tool space. All right, and you have these 4 tabs. We're going to be playing around a lot with these 4 tabs. So you might as well get yourself comfortable with them. Basically, these are all just the different tools and things that you can create in Civil 3D. Alrighty. And there's more of a description on what all these are. What we're going to go over today is something we kind of went over last week, but we're going to be a little more specific this time. It's called a line work code set. So basically, it's just a code within your Excel file or within your survey data that is used to actually draw lines automatically. Okay, so like this BL actually starts a line, and like this EL would be the ending of that line, right? And this asterisk refers to another code that AutoCAD can use. All right, so this would be like overhead power 1, underground telephone 1, underground telephone 2. Okay, so basically these are just references for AutoCAD to know what points are going to connect with which other points to actually create your lines. And the only difference between this and last week is that we're actually going to create layers, and each layer will, import differently and separately depending on which kind of line we're trying to import. Alrighty. And so, yeah, there's a whole bunch of different code sets. You can literally set it to any symbol that you want. You just have to be in communication with your surveyor on what they would want to use for a line work code set to connect the dots. So go ahead and open that Excel file. And what we're going to do is save as and save it to a CSV format, which is one that works well with AutoCAD. All right, so I'm just going to hit File, Save As, or we could go to Export. Let's try Export actually. So Export, change file type, and here it is, CSV, comma delimited. So basically, we're changing it from an Excel file to a text file, basically. All right. So click on that guy and call it master, and I'm going to go ahead and save this guy on my H drive so I always have it. So Civil 3D week 3. I'm going to call this guy master 3 because I already have 2 examples from previous versions. So you can just call this master. You don't have to do the 0.3. Save. All right. Now we have our CSV. And the next step on the instructions is we're going to want to start a new drawing with our personalized template. So that's just something that we're always going to start off with. So then you have your title block, everything set up with your name on it. So just go up to File and go to New, and then it should ask you for a template, right? So just reference back to the H drive, your personalized template. All right, it should have your name on it right there. And it should have your name on it on these other 2 pages too. This letter 11 by 17 and 11 by 17 too. Okay. So we have our new drawing. So next thing we're going to do is set our working folder to week 3. All right, we did a little bit of this last week. So I'm going to go up to survey, right click on survey database, hit set working folder, and then just refer back to the H drive where I have my file stored. So week 3, select folder, there we go. And what I'm going to do is hit new local survey database. I'm going to call it week 3. Okay. And hit OK. And it looks like I actually have 2 of these. You should only have 1 because this is your first time doing this. So, and then right click on the one you just created, the survey database, and then hit open for edit. Okay. Now you see all these options that we can have, all these different things that are inside of our survey database. All right. The next thing we're going to do is actually create our line work code set, which is a little bit different than the one we created last week. This one uses an asterisk as our feature code delimiter. The begin line is BL, continue is blank, so it's just nothing. End is EL. All right, so those are the things we're going to change on this other line work code set. Okay, and that just is all different because this Excel file is different. Okay, if you wanted to change it to the one we made last week, you'd have to go in here and literally type all these in a format that works with the line work code set that we had last week. Okay, so what we're going to do is go to the survey tab of Toolspace, right click on line work code sets, and we're going to hit a new option, and we can call it Sage Eng. So basically that's just, you know, a line work code set that these surveyors at Sage Engineering used when they, you know, gave me the data. Alrighty. So let's go back. All right. So prospector. Where am I going? Survey tab and then line work code sets. Okay. So we're going to go to survey, line work code sets, right click, hit new. Okay. Call this guy Sage Eng because that's what the surveyors are from. They're from Sage Engineering. So we can specify that this is the data they like to use. All right, and so this field code, we're going to change that to an asterisk or a star. Change the beginning to BL. Continue, just backspace, so it's blank. And the end, we're going to do EL. Okay, and then hit OK. You should be able to expand this guy. And you can see that our sample right now is the one that's bold. So you're going to want to right click, hit make current, and you'll see that now this Sage Engineering one is the one that's current. Okay. Next thing we're going to do is actually create 5 new layers. I'm sure you guys have made layers in Bob's class. These are the different layers that we want to set up: vNode break line, vNode U gas, vNode overhead power, vNode util, vNode ditch. Okay. And if you want to now, you might as well change all of these colors so they're all different. You can change them to whatever colors you want. All right, I'm going to go ahead and do that. So if you want to create layers, go to this, make sure on the Home tab, Layer Properties, and then this button right here is to create a new layer. Alrighty, and then we can type in our name. So we want the name to be vNode breakline, vNode BRKL. All right, so vNode BRKL for our break line. I'm just going to change the color to red, because why not? Red. All right. And our next color, or the next layer, is going to be vNode U gas. So new layer. V node U, oops, UCAS. Change this layer to yellow because it's the next one down. V node OPOW for overhead power. So new layer, V node OPOW. I'm going to change its color to green. Alrighty. V node UTEL. Next one. And basically the reason why I'm having them all with V node in the beginning is because typically what I do is anything that refers back to the survey data, I have a V node there just to separate survey data from, things I add later. So we got the UTEL, and then the last one, V node ditch. Okay. V node ditch. I'm just going to change this guy to another color. Blue, why not? All righty. So next thing we're going to do is actually go to figure prefix database, and we're going to create a new figure prefix database. Okay. So go back to Civil 3D. Here's the figure prefix databases. Hit new. We're going to call this one Sage Eng prefix. Okay. Manage figure prefix database. All right. Now we should see this screen pop up. And in order to actually add these figure prefixes, you need to hit a plus sign here. And so these are the default values. So what we're going to want to do is fill it out like this image. So we have the BKLS refers to a break line. And so you're going to want to have a yes click there, change the layer to our newly created break line layer. We want the style to be standard. And with all 5 of these, we just want to have them on survey site. The only difference on the style is this break lines and this EUSD. The ditch, we want to have that one standard, but the middle three are going to be basic. All the layers refer to their own layers, and the top and bottom ones are break lines. Because this one's literally a break line, this one's a ditch. So that's where our surface, we'd want to fold it or mend it, make a crease in our surface, right? So I'm going to go ahead and make those. So rename this guy to BRKS, I believe. BKLS, I lied. So BKLS, break line, yes. Layer, I'm going to hit V to skip down to the V's. V node, break line. And I think this was basic. Oh, standard, okay. Standard, okay, next one. You want underground gas. Oops. UGAS. So this is just the reference that's actually in the Excel file, the UGAS. And we want to put this guy on the V node. Looks like oh, there we go, UGAS. And we want this guy to be basic, I believe. Just double check. Yep, basic. And the next one is OPOW for overhead power. Alrighty. Skip to the V's, V node, OPOW. Okay, next one. UTEL. utel vnode utel. Oh, and I want these to be basic. Basic. And the last one is EUSD for the ditch. EUSD. Yes, I want it to be a break line. I'll translate it to vnode ditch. There it is, and standard. Okay. So now we have our Sage Engineering prefix, make current. Now it's bold, right? So next thing we're gonna wanna do is import these points, right? From the CSV we made earlier, okay? So right click on import events, import survey data, and select our survey database. Next, change this guy to point file, hit the plus to browse. This PC 21, week 3. Yeah, so you're going to want to change the file type to all files, or you could change it to CSV, I guess. So master 3 is my newly created one. Okay, open. No point format match found. Point file. Weird. I knew that it did this for me before. Oh, I know what the problem is. Okay, so if yours is having this issue, what you need to do is actually save your Excel file and close out of it. All right. So let me try that again. Master 3. Remove it. Remove this guy. Master 3. There. See, now I have the green check mark. So for some reason, it didn't like it because I had it open still. I thought I was still editing it. So if you save and close out, it should allow you to import. So then make sure it's PNEZD, comma delimited. Next. And on this one, you can hit next. Import options. We have our figure prefix database, the one that we just created. Hit yes. Insert survey points, yes. Hit finish. There we go. We have all our pretty colors in there. Right. So this guy is a telephone line. This blue one is a ditch, the edge of a ditch. These red ones are brake lines. And there you go. We got it in there. Alrighty. Next thing I want you to do is set up your viewport on a lighter size piece of paper. Add your north arrow, scale, update your title block. All right. So go ahead to your letter layout tab. There we go. And then I'm going to double click in my viewport, unlock my viewport, Hit Z, enter, E, enter for zoom extents. Set this to a scale that works. Let's try 200. No. About 500. Okay, it looks like we're gonna have to go back to 300 again. So custom, add 1 equals 300. Change the drawing units to 300. Okay. Select the one we just made. Ooh, and it doesn't quite fit. Let's go to 400, I guess. There we go. 400 works. All righty. And what I'm going to do next is select one of these points, right click, and hit select similar. And I'm going to change these points to the vNode layer. So all the survey points are on one layer called vNode. And I'm actually going to viewport freeze this layer. So this is how you freeze. This is how you turn layers on and off. And this third one is to just viewport freeze. So that one's a helpful one. It just makes it disappear in only this viewport. So if I go back to model space, they should still be on. If I zoom in enough, see, they're still visible, but they are frozen in this viewport only. I'm going to lock my viewport so I can see my pretty lines. And then go ahead to the layout, double click out here in Paperspace, and then add the north arrow. Select the boundary of your viewport. And then place your arrow, select it, and then drag this guy so it's bigger. There we go. Scale bar. Select the viewport. You know this one's 400 feet this time. Alrighty. So when you print this guy out, use your engineer scale. You can turn it to the 40 side, and it should be 0 and 40 on your engineer scale, which really represents 0 and 400. So you can measure on your sheet any distance in here, find out what your measurements actually are. And I'm going to update this guy to say week 3. Week 3. Scale 1 inch equals 400 feet. Sheet 1. And then you can just print that guy off. So right click, plot a single sheet. And make sure you turn this pen table to none so that you can actually get your colors. Otherwise, if you leave it on monochrome, it'll be just black and white. And I'm not at the college right now, so I'm just going to do DWG to PDF. So it'll print to a PDF. And preview. And it looks like it's not completely centered, but that's just because my PDF isn't set up correctly as a printer. But if you're at the college, you can select that printer over there, print, and there you go. That's how you do the assignment for week 3. Hope it was helpful, and I will see you guys later.